Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this recap of week 2. So the first thing we learned was simultaneous equations. We're just going to look at the elimination method because that will come up later. So here we have two equations. We want to find a value of x and a value for y that satisfies both equations simultaneously at the same time. So, to use the elimination method, our goal is to eliminate one of the variables x or y. To do this, the x's or y's need to have the same coefficient in both equations. If they don't, we're going to need to multiply one or both equations. So if I multiply this top equation here by 3 and the bottom equation by 5, the x's will then have the same coefficient in both equations. So multiplying the top equation by 3, I need to multiply everything in the equation by 3, and for the bottom, I need to multiply everything in the bottom equation by 5. So now that the x's have the same coefficients, I can eliminate them. Here I'm going to need to subtract to get rid of the x's. If they had a different sign, like one was positive, one was negative, I'd add, but because they have the same sign, I'm going to subtract. 15x minus 15x is 0. Minus 12y minus 45y gives me that. 57 minus 285 gives us minus 228. Dividing by minus 57 gives y equals 4. Now I substitute into any of the equations, I'll just pick this one here, to find x. So 3x plus 9 times 4 equals 57. Subtract 36, divide 3, you get x equals 7. So y equals 4, x equals 7 satisfies both of these equations at the same time. All right, let's now have a look at quadratics. So firstly, let's look at solving quadratics by factorization. So all you do is factorize, then use the Null Factor Law. What makes it difficult is that the method we use for factorization changes whether it's a binomial and has 2 terms or a trinomial with 3 terms. So for a binomial with 2 terms, you either use highest common factor or difference of 2 squares. So if there is a common factor, you use that. So the highest common factor of 4x squared and 10x is 2x. So I take that out of the brackets. Then what do I times by 2x to get 4x squared? What do I times by 2x to get 10x? So now the null factor law says either the first thing is equal to 0, which would mean x is equal to 0, or the second thing is equal to 0. If 2x minus 5 equals 0, x would just be 5 over 2. And then we're done the first one. So now let's look at this one. So if the binomial doesn't have a common factor, here there is no common factor, it's difference of 2 squares, where you have a perfect square minus a perfect square. So you factorize like this. We're going to get 2 brackets. So you're going to start by square rooting the first, then square root the second, so square root of 1 is 1. 1 gets a plus, 1 gets a minus, doesn't matter the order. So then null factor law, either the first bracket equals 0, which would give x is minus a half, or the second bracket equals 0, x would be positive a half. All right, let's now look at trinomials. So that's when you have 3 terms. So if the trinomial is monic, meaning the leading coefficient, the coefficient of x squared is 1, you just use the sum and product. You find 2 numbers that multiply to the constant term and add to the middle term. So those 2 numbers that multiply to minus 40 and add to minus 3 are minus 8 and positive 5. Now, they are not the solutions. They just go in the bracket. The solutions are if x minus 8 equals 0, x equals 8. And of course, if x plus 5 equals 0, x equals minus 5. They are the 2 solutions. So if you have a trinomial that's non-monic, we need to use the AC method. So a is the number in front of x squared, which is 4. C, the constant. So AC here is 4 times the number, which is 36. So now what I need to do is find 2 numbers that multiply to 36 and add to 12. So they're both 6. So I split up the middle term with those 2 numbers, 6 and 6. So then I am going to factorize the first 2 terms separately to the last 2. So for the first 2 terms, highest common factor is 2x. So then I put in 2x plus 3. The highest common factor of the last 2 terms this time is 3. So I take out 3. What do I times by 3 to get to 6x? What do I times by 3 to get 9? Okay, and then you should see there's now a common factor here of the brackets. So that common factor is the first bracket. What goes in the second bracket is what's left, 2x plus 3. So this is actually a perfect square. I've got 2x plus 3 all squared equals 0. So there's only one solution this time. If 2x plus 3 equals 0, x equals minus 3 over 2, and we're done. All right, let's now look at the quadratic formula. So sometimes those methods of factorizing just won't work, and we need another way to solve quadratics, and that's using the quadratic formula. So the quadratic formula involves a's, b's, and c's. So they're the coefficients. A, the coefficient of x squared, b, the coefficient of x, and c, the constant term. So this bit under the square root in the quadratic formula is called the discriminant. If the discriminant's negative, there are no solutions. If it's 0, there's one solution, and if it's positive, there are two solutions to the equation. So let's look at this equation here. We're going to use the quadratic formula. So my advice is first step is calculate the discriminant. So it's b squared minus 4 by a by c. So in this case, you get a discriminant of positive 57. That means there are going to be two solutions. Because it's not a perfect square, they're actually going to be irrational. So the solutions here, we're going to have x equals minus b, so minus minus 5, plus or minus the square root of the discriminant over 4. So there are two solutions, 5 plus root 57 over 4, or 5 minus root 57 over 4. So let's just look at one more question involving the discriminant. So what is the value of k if this equation here has only one solution? So if a quadratic equation has only one solution, that means the discriminant is equal to 0. So the discriminant is b squared, so in this case b is k, minus 4 times a times c. So the discriminant is actually k squared minus 576. And that has to equal 0 for there to be only one solution. So now I'm going to solve this equation. This is a binomial. It's difference of two squares. There's no common factor here. So 2 brackets, square root the first, square root the second. 1 gets a plus, 1 gets a minus. So either k plus 24 equals 0, which means k is minus 24, or k minus 24 equals 0. They are the two values for k. So it turns out if k was minus 24, the only solution here would be 4 over 3. And if k is equal to positive 24, the only solution here would be minus 4 over 3. All right, thanks so much for that. Keep your head up. You're doing an awesome job. This has been the luckiest maths teacher in the world. Have a great day.